Hello everyone. So, last class we studied about successive differentiation. We figured out a little bit about what successive differentiation is and how we come to the first derivative, second, third, and so on till the nth derivative. So, now I think it's time to start some general formulas. And by general formulas, I'll only explain one because I think what most of us do is cram a lot of formulas at one go. And since we don't know what the first one means, we kind of screw up the rest of the formulas. So I'll go slow and I'll go simple so we save time for future. The first one I'll take is that the function y equals ax plus b a whole power m. Now keep this in mind that n will be our nth derivative and m will be the power. The power means this power. So keep this in mind. And now moving on to this function. If I want to find the general formula for this particular function, there are a few steps which I'll keep in mind for each equation. The steps are: first, I'll write 4 derivatives of this. I'll take first derivative. So by using the derivative formula, the power rule, which is y dy upon dx equals to n x and minus 1. If I have a function x raised to the power n, this is the formula. I'll apply this formula in this equation. So m's comes in front times ax plus b, then 1 is subtracted from the power m minus 1 times, using chain rule, there will be an a. Now why an a? Because chain rule says that every single thing should have a differentiation. So if I'm doing dy by dx of ax plus b, this b is constant, so it will be 0, plus this x will turn 1 times a. So I get a. Now this is the first derivative. I need to find 3 more. The second derivative will be m. This m minus 1 will come down, so times m minus 1. This is important to understand. And then 1 is subtracted from the power ax plus b, m minus 1, and then 1 is subtracted, so m negative 2. So m minus 2 times a, and then we find the differentiation of ax plus b again, so it comes out to be a. So a times a, or I can just write it as a squared. I hope this is clear. So similarly, doing the same for the third derivative, we have m as it is, we have m minus 1 as it is, times this m minus 2 will come down, so this will be m minus 2 times ax plus b as it is. Now m minus 2 minus 1, which is m minus 3, times a square into a, which is a cube. Now the fourth derivative should be very easy now. m minus 1, m minus 2, m minus 3 ax plus b minus 4 times a to the power 4, because we don't have any analogy for a to the power 4. Kind of unfair, but okay. So now we come to this particular equation, and this is a bit unique because now we have to find a general equation from this equation. General equation meaning we have to write the same equation in its nth form. So we need to find our nth derivative and the equation, general equation, what will be, because I cannot keep multiplying these terms. I need to find a stopping point, and I also cannot write, which most people make mistakes. I'll address this later. So first what I'll do is start with the easy ones, like right here. Let me change. I'll take a. So I'll go back and I'll find, for the first derivative it's a, for second derivative it's a squared, for third is a cube, and for fourth derivative it's a to the power 4. I'll write these down here. So for y first derivative it's a raised to the power 1, which I can write. For second derivative it's a squared, third it's a cube, and fourth it's a to the power 4. So after this I'll move on to ax plus b. I'll go back to the start and I'll check that for first derivative it's ax plus b raised to the power m minus 1. For second derivative it's ax plus b raised to the power m minus 2. Third it's ax plus 3 raised to the power m minus 3. And lastly for 4 it's ax plus b raised to the power m minus 4. I think you guys can start seeing the pattern here, which will help us in making the general equation. I'll quickly write this here. For first derivative it's ax plus b raised to the power m minus 1. For second it's ax plus b raised to the power m minus 2. For third it's ax plus b raised to the power m minus 3. And lastly for 4 it's ax plus b raised to the power m minus 4. So we are done with the easy ones. We have covered this and we have covered this. Before starting with this part, let's generalize these two. Now let's see a pattern. For first derivative it's first power. For second derivative the power is 2, 3 it's 3, and 4 it's 4. So for nth derivative I can write it a raised to the power n. Yeah. Similarly for this one I can write it for the nth derivative. Ax plus b remains same, ax plus b, and for 1 it's m minus 1. For 2 it's m minus 2, 3 m minus 3, 4 m minus 4. So n it will be, yes, m minus n. Yes, you were right. Okay, so now our equation is almost done, our general equation. So now what we're missing, we have covered this, now we need to figure out how we can write this part into a formula. I'll just write this again. It is y fourth derivative as m m minus 1, m minus 2, and m minus 3. Now, to write this into a formula, first we need to know the reason why. This is an important part. This is the important part. So please pay attention. If I want to find the general equation for this term, it will just be m minus 1, m minus 2, dot till whatever nth term I have. But if I write this, it will be absolutely wrong. And I'll give you 2 reasons why this problem is wrong. First of all, this will take forever. The calculation will be way too much, and there is a 90% chance that you will make an error or I will make an error. And why did I say calculation? It's because, let's take an example. Y equals x raised to the power, suppose 50. And I want to find the 20th derivative of function y. Now, if I manually decide to solve this question, I will turn old. This will take so long. My first will be 50 times x raised to the power 49. My second derivative will be 50 times 49 times x raised to the power 48. My third derivative will be 50 times 49 times 48 times x raised to the power 47. And I have to do this till y equals 20th. We cannot do that. It's not gonna work. We cannot do that. So this is why calculation is gonna take forever, and there is a high chance that we're gonna make error while calculating, because multiplication is no joke. And the second reason is it is not something a computer can understand. And why did I say that? Because of this right here. Because of this. Now, what is this? I call it the dots because they are the dots. And computers cannot understand these dots. They do not know how long they should multiply something for. So if they see dots, they're gonna give you error, and error is no good. So computers cannot read these dots. They need precision. Computers cannot work without precision. So that's why, because of these 2 reasons, and I think the first reason is enough to know why we're not going to use this, even though no one's going to care about the second reason. Same with me. We cannot use this formula. We need a general formula for this. So I'm going to explain it to you guys in a simpler term. I'm going to take another example. Okay. I'm going to take an example. Y equals x raised to the power 10, suppose. And I need to find the 4th derivative of this function. Now, I can calculate the 4th derivative manually. So I'll do that. I'll find the first derivative, which is 10 times x raised to the power 9. Second will be 10 times 9 times x raised to the power 8. Third will be, I should write, yeah, I'm sorry, 2, 3, 10 times 9 times 8 times x raised to the power 7. And my last one will be 10 times 9 times 8 times 7 times x raised to the power 6. So from this, we're gonna find the general equation for the multiplication term, which was this equation. And how are we gonna do that? I'll explain it to you very simply. First of all, we need a starting point, which we're gonna take this. I'll change the color. This 10 is our starting point because it's the first multiplication that comes down. And 7 right over here is our ending point because we need it till 4. And the fourth derivative gives us the ending point as 7. So now we have a start point. I'll write this as start. And now we have an end point. So, and the third, okay, so first let's write this down, what we already know. We know we have a starting point, which is 10. We have an end point, which is 7. Now to come to this solution 7, because we need to tell the computer when to stop multiplying. For example, in this equation, we need to stop multiplying at the fourth derivative, which is 7. But the computer doesn't know that. If I just write ... it won't know unless I tell it a specific number. It needs precision. So for higher values, we need a simpler formula to save us some time and our senses. So to get to this solution, I'll also find something else. I'll write the steps it took to teach our solution, which was 1, 2, 3, 4 steps. So I'll write here steps, which is 4. So can I come to 7 somehow using these two? What I can see is I can write it as 10 minus 4. But 10 minus 4 is 6. It's not 7. So to make it 7, all I do is add 1. Yeah. Add 1. That's what we're gonna do. So I can write it as the starting point 10, negative, the steps, and it adds 1. So this gives us the end point. Now how I'm gonna write this into a solution? I'm gonna take, okay, I'll write this as starting point minus steps plus 1 equals the end point. Okay, so to get this answer, the starting point we took is 10. So instead of writing 10, I'll write something else. So if you come up here, you can actually see where I got this 10 from right here. And what is this called? I told you above, this is nothing but the power of m. I mean, m is the power, so it's m, and 10 is the power. So I'll write here m minus, now this 4. If we come back up here, 4 is the number of steps, and 4 is also the derivative which I need to find. So what is this? I called n as the nth term or the nth derivative, and here the 4 steps are nothing but our n, and then plus 1 is to get the answer correctly. And I'll also tell you why we add the plus 1 and how it proves, because math is nothing without proof. We get this solution for now, and let me explain it to you again. I'll take the example again. Y equals x raised to the power 10. We need to find till the 4th derivative, and this is very interesting. First derivative will be 10 times x9, x raised to the power 9. Second derivative 10 times 9 times x raised to the power 8. Third derivative is 10 times 9 times 8 times x raised to the power 7. And finally, the fourth derivative is 10 times 9 times 8 times 7 times x raised to the power 6. Now I'll make a section here now. I'll write this part as the derivative and this part the starting point. Now the derivative goes 1, 2, 3, 4. So I'll write here 1, 2, 3, 4. And the starting point for each derivative goes here, it's 10. Because it's right next to x, you can also remember it that way. And here it's 9, here it's 8, and here it's 7. So it goes 10, 9, 8, 7. And we needed to find a solution, an equation to make a general equation. Okay, what I said was silly. So we come to this part, okay? We took derivative on one side and we took the starting points on the other side. Now we needed to make an equation which involved these two, which somehow combined, or which somehow involved these two parts to make the equation. So we took the 10 as a starting point. We only took the first term and we subtracted it by 2. What is 10 minus 2? It's 8. But 8 is not equals to 9. So what we did to get the correct answer, we added a 1. So we get resulted in 9. And it is correct. And then we took the same 10, the initial starting point, and we subtracted it by 3. 10 minus 3, which is 7. 7 is not equals to 8. So we added a 1 again. And we got the correct answer again, 8. We took the same 10, the same starting point, and we subtracted 4, the fourth derivative. 10 minus 4 is 6. And again, we didn't get the correct answer. We always get 1 off. And to solve this problem, we add this by 1. So 6 plus 1 is 7. And it is correct again. So that's how we proved m minus n plus 1. Now we're gonna use this equation back to the start. So our initial equation was y equals ax plus b raised to the power m. We needed to find a general equation. So we found for m, so I'll just write it real quick. The first derivative, m times ax plus b raised to m minus 1 times a. I'll only write 2. M times m minus 1 ax plus b m minus 2 times a squared. Okay, so we already solved for this, and we have already solved for this. Y, for the general equation, y raised nth derivative of y is for a, it was a raised to the power n. For this, it was ax plus b raised to the power m minus n. And now for this dot term, we came as m minus n plus 1. Now this is our general equation. This is our general equation for this problem. Okay, it took really long to explain only one, and it also feels a bit silly to only understand one topic at a time, but I thought it was necessary. And I hope in future, when you don't understand something, you'll remember this video and I maybe helped a little bit. I don't know. But it really helps me though. So yeah, I guess this is it for now. I'll probably speed things up from the next class and explain a bunch of new general formulas. So stick around for that. And yeah, that's it. Let me go to the top. General formulas for successive derivations. Differentiation.